Hey, so you ever go to a website and then like you're like, hey, I'm gonna get all the information that I need, and then all of a sudden like you click the link and then there's just porn.
we're not opening with that. So do you want to? Sorry, that knocked me out a little bit. Do you want to? We should talk about that story. That's kind of a real story.
Yeah, it's yeah, like it's
give the context.
yeah.
To that story.
So we were hosting this website for one of our clients, and it was a static site that was using .nuke or something.
.net nuke. It's a content management system.
Yeah. So and we were trying to get everyone moved over to Umbraco because it was so out of date. .net nuke wasn't being supported anymore at the time, so it was just like, all right, we need to get people moving.
Yeah.
And the client's like, well, no, we like our site. We don't want to change it.
Well, and they had a feature that they paid for that
integrated with the main application.
Yeah, and
now, luckily they were decoupled, so like whatever happened didn't breach anything.
But they didn't want to pay, or we couldn't get them to agree on how to redesign this feature in the new CMS, the new Umbraco, which was going to be cloud hosted, was going to be patched automatically. The client dragged their feet on it for well over a year.
Long enough for somebody to find the vulnerabilities and make unintended changes.
Yeah, they were using our server to host links to pornography. So the actual porn itself wasn't hosted on our site, but there were links
redirects
to it. Yeah. And they did it because of a known vulnerability in the CMS at the time where you could essentially update content without a login. And that is like the biggest risk in using any sort of
anything out of date, or if something has a security patch and not taking advantage of it right away.
I was going to say with a well-known third-party system, because like once those vulnerabilities are leaked, or not leaked, once they're made public, that's when the hackers just write their little crawlers and just try on every single site they can get their hands on.
Yeah, and if you're hosting a site or anything too, like I'm sure you see this on a regular basis, but WP-admin for WordPress.
Yeah,
like it's a well-known URL, and you're gonna see those bots just crawling, just trying to find, all right, let me try these 2-3 passwords or whatever it is, and then give up and then move on to the next thing.
Yeah, I remember talking to a business owner, and I like showed them the logs of traffic from Russia that was hitting our servers looking for those type of backdoors, and I'm like, we need to do something here. We need to implement some sort of geofencing or what. And the owner was like, there's no way we're being hacked. Like no one's targeting us. And I'm like, you don't get it. Like it's not a person sitting behind a desk doing this. It's a bot. It's just crawling the entire internet. And it finally clicked like, oh yeah, like hacking isn't like it's done in the movies where
not
you got
anymore.
Developer,
or you got to get onto the payphone with the special decoder or encoder.
It's all done using crawlers, and once the crawler identifies
and they're
target,
so easy to make. It's like 10 lines of code. Like ask ChatGPT, like, hey, can I get a web crawler? Boom. Done.
I mean, it was making good ones early on, and then it started to they had to dumb down ChatGPT because it was creating really good ways of circumventing security.
Yeah.
But yeah, that was a true story. And we were targeted because of a crawler found that we were using an old version of .NET Nuke, and
like flagged it saying like, hey, vulnerable.
Yeah, and then they probably ran another program that tried to inject malware into the server, and it was all because we had a client who refused to do an upgrade, and our policy at the time was all change has to be approved by the client, and the client doesn't care. They don't understand the risks, even when you articulate it to them.
Because what they hear is, and especially in this case, you're moving from one system to another. Well, there's going to be a UI change that's going to shock people.
Yeah.
So
And security is one of those things where it's never going to be a priority until
it's a problem.
It's a problem. And then the developer is going to be the one to be blamed. Like you were telling me, and we won't go into the specifics of it, but you were telling me about recently some shade that was thrown our way about a design choice. And I know for a fact that
we talked about it day one of implementation.
And it was, it's not that big of a deal, or we don't really need to worry about it. And the costs associated. It was basically, it was an issue that was oriented around authorization. So we had an API that it would check to see if you're authenticated, but when it came to authorizing what you had access to, it was considered to be a nice to have feature. Like it's once you're in the system, who cares what data you can access? Fast forward 8 years, and all of a sudden that's a hot pressing issue for a variety of reasons, which we won't get into. And the question is, well, why didn't you guys do that? And what it really boils down to is there wasn't a strong enough business case at the time. And if you don't make those changes day one,
it's so much harder to do later.
Yeah, so it became it wasn't important then, and it was impossible to do later, and now it's an issue now, and developers just got to do a better job advocating for security.
Yeah, well, I think the biggest part too is just identifying like what those risks are or how somebody can attack it.
Yeah, but I'm like I know for a fact we did in that instance.
Oh, I do too, because I'm sure I have notes that say, hey, like, out of these things, like these are the 100 things we got to do. Like, what are the top 50?
Yeah, like role-based access was always like a hot button topic, and it was always determined that we guard it on the UI, so that should be sufficient. Like, who's gonna? I've heard this numerous times. Who's gonna go grab their token and
the URL and because the users aren't savvy enough.
Yeah, that was the story.
When it comes to security, like there's certain things that just need to consider, and there's really a lot of it comes to, again, what are you thinking and what is the risk management of it. And there's a lot of security features that are in place, and they're in place for a reason. So we were talking about API access with using a token. Now we were using bearer tokens. So if you go to jwt.io, you can put a bearer token, you can see credentials and information out of it.
Can I just give a brief summary of what a bearer token is, because some people might not know. So imagine a token that identifies who you are and what you have access to, and it's good for a short amount of time.
Yeah.
That token is technically not private. Like, you can generally see it in the HTTP traffic.
But there's a private key on the server that validates it.
Yes. Yeah, so you can't just like forge it. You can't just like modify it and then resend it up, because it's validated that the token that you were sending it was actually intact. It hasn't been modified.
And this is kind of why there's third-party authenticators like Google or Facebook or something that's popular, is because the Facebook or Google, they're taking the risk of the managing the keys. And your application, what you're setting up is you're setting a thing known as the quote-unquote authority. So when it gets a token, it knows who to go back to say, like, is this thing valid or not?
Yeah, so the token itself identifies who can validate it. And the other piece of information in this token is how long is it valid for?
Yep.
Because it's a stateless token, so it's not like you can take this token and reuse it a year later and it's going to like work. Yeah. So generally,
it could if somebody set it up that long.
Generally speaking, you want a token to be very short-lived, and there's ways to regenerate them using like refresh tokens, but you want that access token to be very finite. And we're talking like 30 minutes is probably as long as I would have it.
I think an hour is the industry default.
Yeah.
But like
shorter the better.
Yeah, shorter the better.
The downside to making it shorter is when it invalidates, there's some client side logic that's got to run, and then to reissue another token adds a little bit of latency.
Yeah. Now with the advent of like single page applications, then that's what's known as a silent refresh.
You don't even see it happening.
It just kind of does it. it's funny because it actually opens an iframe and then it does a communication with that and then
But
it'll
it's also-
close it
yeah,
up.
it's
But nobody knows. You just say, it needs to do it.
So we had a client who I don't even remember why they were mad that the tokens were expiring.
It wasn't about expiration. It was about validity. So one of the other parts of this token was there is a not valid before time.
An NBF. Yeah.
Yeah. And their computer
Oh, they forgot to update their clock.
was 5 seconds slow or fast. It was 5 seconds fast. So the token always thought it was being generated in the future. And when the server got that information, they're like, you generated this in the future. You can't, how to do time travel? This doesn't make any sense.
Yeah.
And the main thing for this was they were on their own intranet system, and instead of using Microsoft time for their clocks, they used whatever server that they had in the office. They never restarted that server for a long time.
Clocks drift over time if you don't reboot it. Yeah.
So, and they never went to go synchronize it back to Microsoft or anything else. They just said, yep, this is system of record, whatever it is. And that was like a week of just trying to figure out like what's going on with this, because we're like, we can't reproduce this until we got on the call with the person to figure it out. Now this might be the quote, the horror story of like where security might be a problem, but like honestly, it's there for a reason.
Yeah.
Like they shouldn't have been authorized because they were doing something shady. They were using things in an unintended use case, and then they were getting bounced out.
Yeah. The NBF is generally there if you're going to create a token now that's intended to be used for a short period of time in the future. You would set that NBF to like whatever that time is, and you'd set the expiration to be a limited time, and then you can hand that token to them with confidence that they're not going to like run with it and do all sorts of crazy stuff outside of the time that you create it for.
Right.
But I do remember though that the question of how long should the token live.
Yeah, because you can put so with that, not before, you can do a plus or minus time frame, which essentially helps with the validity of the token in the first place.
Yeah.
And then that's sort of the question of, all right, how long should this thing, what should the plus or minus be? Well, we don't know how far people are going to drift, so I don't know, a year.
So much that it literally made the feature
pointless.
Yeah, now we have these tokens that could be used way outside of what would be considered normal, and it's not good. And the other thing too with having a short life cycle token is it results in the application needing to re-verify that user is authorized. So let's say you revoke permissions or you disable their account. If that token's lifespan is too long, you're never going back to the authority to say like should this person be accessing this system,
right?
Because again, OAuth is meant to be a somewhat stateless protocol, so you're not making so many round trips to the server. Having that lifespan be a year in the future is almost pointless.
Yeah. So every single time I log into my virtual desktop right now, you have to put a pin into a thing to get a code and then put it in as part of your login process. Not a problem. What I found out is you can put whatever pin you want in there and it's going to generate a code. However, it will generate the wrong code.
Nice.
So like this is I know you weren't going down this way, but handling security is it's not telling you if the pin's right or wrong. It's going to give you a result thinking that you're right,
which is smart.
And so it's like username and password. If you're unsuccessful for logging in, normally you'd be like, oh yeah, of course your password is wrong. Well, no. You want to be generic. You want to be like, oh, it's a username or password.
We had that problem. I remember talking to a stakeholder and I said, look, you want the login screen to tell you which is wrong because you think it's a better user experience. If my username exists, tell me my password's wrong. If the username and part of this was because we were moving from one login system to another one. A bad login system to a better one.
Yeah. But it was so we were migrating usernames, but we weren't migrating passwords. Well, I mean, we probably did, but we migrated usernames, and what they wanted us to identify was your username's here, but you haven't claimed it yet. Versus, no, that username doesn't exist. You need to make a brand new one.
Yeah.
And then also like, okay, and then check your password. And if your password's wrong, then like fix that.
Yeah, but like the best practice is say username or password is wrong. Don't give any indication as to which one's incorrect, because if you tell them your username's correct, you've essentially created an API to...
You solved half the problem for a bunch of people.
Yeah, like let me just put in... So I got let's say I download a bunch of cracked... passwords, cracked accounts. I'll just run those usernames through this server, and whichever one doesn't tell me username's incorrect, now I'm going to brute force passwords or try a password dictionary.
And this is where it's really important not to have those things open authentication or also return. It's more okay. Not saying it's great that the internal system might know, but when it gets returned back to the client, even through the network, you don't want to say is one or the other, and then just have the UI handle it, because you can still sniff that information out.
Let's talk about what developers need to do in order to address these security issues. And I'm gonna start with the principle of shift left. Have you ever heard of that?
No.
Okay, so I've been doing a lot of research into the DevSecOps and the whole idea with
DevSecOps being development security operations.
Yeah, it's the idea. Like traditionally, the old model is you got DevOps and then you got security, and security is kind of an afterthought. It's sort of brought in on top of everything. The idea behind DevSecOps is security is sort of woven into every part of your DevOps practice. Mm-hmm. Every step has some element of security. And this idea comes from this shift left model where imagine a workflow where you start on the left side, you're doing your design phase, your development, your testing, your deployment, your CI/CD pipelines, your release, monitoring. Typically, security is heavy on the right side of that process.
Just make sure things don't get out at the end. Yeah. But everything internal, it's fine because it's internal.
Shift left is how do we bring more of that over here earlier on, because as we've talked to in the past, as you move change to the left, it becomes cheaper because you're
doing it right then and there.
Yeah. So shift left is this idea of like, let's bring security best practices early in the development phase. One of the first times I was exposed to this, and this isn't even really shift lefty, was we had a client who insisted that we did a static code analysis as part of our
regular,
DevOps. Yeah. So this idea where we send a compiled version of our software to a third party, they analyze it, they give us feedback, and then we act on that information.
Whether it be development pattern or whether it be like dependency issues. So like in the case that we've talked about for the
.NET Nuke.
the .NET Nuke situation,
it would have
caught that.
Yeah, it would have said, hey,
we already knew that, but like this would have at least had some formulation of a report. Like, no, like here's a problem.
Yeah, we did, but not everybody did. Like the developer responsible for maintaining it knew, but it was never communicated to the business well. It might have said, hey, there are some security patches, but it wasn't, hey,
the security patch is going to cause this.
Allow these things. Yeah, where the static code analysis is going to give you a better summary of that. So yeah, my first exposure to it was this Veracode. That was the company we used, static analysis. But Veracode was always viewed as a trouble. It was a bother. It was we don't really want to do this. We don't value it. So really what we lacked, at least at that time of an organization, was a culture of security. It wasn't viewed as anything that was important. Mm-hmm. It was going back to that.
Get stuff out. Not stuff good. Well, I mean, stuff good, I guess.
It was
great.
It was that whole 1980s hacking trope. It's like, well, no one's gonna target us. We're this little company. It's like, well, no, you don't get it. Hacking isn't done by people. It's done by programs. Programs don't care. They cast a wide net.
And when it's people, it's normally social engineering at that point. And it's an individual. It's not like a whole system.
Yeah, but now with AI, even those social engineering things are going to be fully autonomous.
Easy.
Yeah.
I mean, that stuff was already out there. Like how much stuff do you put on Facebook? I know you don't have one, but for people that put their whole life on there, you're
grab my tinfoil hat and put it on. Yeah. So, I was exposed to static code analysis maybe 7 years ago. we never really valued it. And as a result, we never put security into our practice. It was always viewed as this negative thing.
Yeah, it's when we had to do it, we would bring things up to snuff at that point.
Yeah. So fast forward, like we find ourselves in a situation where security is of the utmost importance, and there's been a lot of like questions surrounding why didn't we make the right choices to address this, and ultimately what it boiled down to is we didn't value it at the time. We didn't address the technical debt. And now we're in this situation where this hole is only getting deeper. We're only falling further down.
Yep.
At some point, you got to just say, we're going to pause development and we're going to address this issue. And this whole idea of like shift left is incorporating security into the culture of the organization, the culture of the team, so that you're not in that position in the first place.
Yeah. So hearing you explain that, like another thing that kind of comes to mind, and I guess I might have been doing it on the onset, but I think it's a pretty common idea is don't check your secrets in, right? Your connection string with your username, password, or something secret, or like an API key. Honestly, like some of these YouTube videos, I've been looking into like LLMs and like using AI like backends and stuff. And some of them just have their API keys just sitting on there, not blurred out or anything. It's like, oh shoot, like you're giving stuff away. Like maybe it's a test account, maybe it's not, but like you're doing something.
Yeah, that's a good example of like that shift left mindset where even like during development, like we might have hard coded connection strings or like passwords and like your app settings.json file.
Right. And then like that's where the deployment system, like Azure DevOps or something like that, helps obfuscate the production environment settings.
Yeah.
Assuming you separated them in the first place.
And that's like we did that. Like we had those credentials, those higher level credentials stored in secret places, like in the app settings section in Azure, where only like an operations person can
it's
get
very
to.
limited. Yeah.
But even that isn't really sufficient. Like you want that stuff in a key vault or something that's even more secure, because you're assuming just because I have access to the settings page in an Azure like portal
doesn't mean that you can't sniff it out.
Yeah. You don't want that.
Yeah. So a key vault is just like another. It's really a more sophisticated dictionary, I would say. You need to have a username and password to access it. You give it, your key, and then it's going to barf out the value for you.
Yeah. So with this shift left mindset, you're going to run these linters. You're going to run these static code scans in your IDE. You're going to run it in your CI/CD pipelines, and it's going to catch these things.
Yep.
And the earlier it catches it, the better. Like you don't want to wait for the build to catch it. You want to be running this thing just like when you build to check for compilers. You want to run this linter. You want to run this localized scan to catch these things, and they're smart, especially with AI now. It's like I one of the ones I love to use is SonarQube.
And I'm just getting into that now myself.
Yeah, and it's free. There's literally no excuse not to use it. You can download the community edition for free.
Integrate into Visual Studio, VS Code, wherever you need it.
And it supports all of the, I'll call the major languages right out of the gate. It doesn't do SQL, but it does like C#, Python, JavaScript, TypeScript. And it'll tell you, it's like, hey, this looks like a connection string. This has the word username. This has the word password. This stuff is hard coded. It should get moved out.
Yeah. And they also have code smells too, which is that's what I've been experiencing and seeing some legacy stuff. Just like, hey, this looks like it's reused in 10 different places. You might want to consider changing this.
Yeah. Like a lot of times, like companies don't look at tech debt as a security vulnerability, but it accumulates like a snowball, and it gets in the way of changes you need to make in order to keep your code up to date. My wife, she works for a company who is still running .NET 4.5, and they're at this point now where they need to upgrade.
Yep, because Microsoft stopped supporting that.
And they can't. They literally can't without rewriting 90% of their app, and they've been kicking this problem down the road by creating holes in their security posture. And it's gotten to a point now where I almost laugh at the fact that like you guys keep saying you don't have time to deal with this. You don't have time not to deal with this. you have to like address this, otherwise your entire business is at
Gone.
risk. Yeah. And the reality is a lot of businesses just don't see it that way. It's and you know, more modern like companies do, but it's the older companies that have been operating for 20, 30 years who their mind is kind of still stuck in the 90s.
Well, and I think this is part of the difference between, you know, do you host something yourself or do you put something out like on a cloud? Because those clouds, like, they're going to force you to upgrade.
You're still obligated to do all those patching. And we actually ran into that when we needed to upgrade SQL, and we couldn't because we had to do a bunch of Windows updates and we had to upgrade the version of Windows. It was a nightmare. Platform as a service, PaaS, that's a little bit different. Now you start getting into you're abstracting away more of the hardware. And generally when you do that, you eliminate the responsibility for the company to have to upgrade.
So I imagine this is probably where like .NET Core is advantageous because it doesn't matter if you're running on a Windows machine or Linux machine, like it's just going to run on whatever you put it on.
It's probably why Microsoft like pushed hard at you know, doing that, is because they, you know, your typical app service or your microservice you shouldn't care if it's a Linux box or a Windows box. But we saw this when we were picking database technologies, because we were using a traditional SQL server hosted in the cloud, and we were kind of, our hands were tied. We couldn't upgrade. And then we shifted over to a managed instance, which is kind of a hybrid where you still have the dedicated SQL instance, but all of the OS layer was removed.
Virtualized.
Yeah, so we didn't have to worry about Windows updates anymore. But you can even go a step further and you can get into like hyper virtualized instances where you don't even really have the concept of a server anymore. You're just running SQL in this elastic pool of cloudness.
Yeah, it might be one server, might be 10 or 100. It depends. Whatever you need it to be, it'll just do it.
So as like generally as you move towards that serverless model, I was talking to a developer today about the difference between serverless and server full, I guess, cloud, because he was like, well, it's in the cloud, it's serverless. I'm like, well, no, to be serverless means you sort of separate compute from storage. Those two things get removed. And we were building out we were sort of working through like deploying a Synapse instance in the cloud. And I was talking about like the reason I love Synapse is it's serverless. You're only paying for the time it takes to run the queries when you run them. And then after that, like you're not paying anymore. But as you move to that serverless model, generally it gets more secure.
Yeah.
So I always advocate for companies, businesses, products to like default to like software as a service, serverless architecture first, and then shift over only when
you need the functionality.
You need to, yeah, because you're the more you can put on the hardware or the cloud vendor, the better your security posture.
Because they're going to just do it.
Yeah, they'll do it. They'll do it better than you. They got a team of experts. Now there's a cost to that, right? But if you build your code to be optimized in that space, generally I have found the cost is kind of a wash, because if you write like hyper efficient code that can take advantage of the elasticity, sure, you might be paying more when it's running, but when it's not running, you're not paying anything.
Yeah. Or it's easier to scale up or down as well.
Yeah. So there's a lot you can do, and like from an infrastructure standpoint, from a coding standpoint. But at the end of the day, it involves a culture of security, and it's hard to do that unless you have buy-in from every level of the organization.
Yes, security is everyone's problem, not just when it is a problem.
Not just the operations guy's problem. Yeah. So I don't know, that like it's worth, like I would encourage everybody like to at least think about how your organization does security. I'm curious if like, you don't need to go into detail, but are you guys doing anything that is not so above board?
Yeah. So whether it be, you know, again, like role-based access, like I think that's a real common thing to consider.
Least privilege, the whole philosophy of that. I remember talking to, I don't want to go on this tangent too long, but I remember talking to my security guy, and I always viewed security as like this pyramid of and the higher you go up in the organization, the more access you have.
Yeah.
And he was like, no, it's literally the other way around. The higher up you go, the least access you should need, because you don't need access to that data. Like, there's no reason the owner of the organization should have access to your key vault.
Yep. Yeah, what's he going to do with it?
Yeah, it's literally, he does not need this in order to do his job, so we're not, like, you should not give him access to that. And that just goes back to that old archaic way of doing structure. It's like, the owner's the king, right? And the king has...
They should have the kings of the kingdom.
Yeah, he's got sovereignty over his land. He can do whatever he wants. And it's like, well, with least access, it's almost like that on its head. It's
because you're putting gates or barriers in spots. So, like, I know even for getting production access, right? Like, nobody has production access except for the application to the application. And if you need it, it was for a window at this time, and you had to get approval for it.
Yep.
Like, it was a very deliberate reason.
Yeah. So, like, just think about how your organization does security. Least access is a great example of one that I would bet a lot of companies don't actually implement correctly. Role-based access has been, like...
It's pretty industry standard.
Yeah.
Yeah.
But that, like, ask yourself, like, does my boss have more permission than me? Does my boss's boss have more permission than me? And sometimes that is, like, how it needs to be. But generally speaking, that sort of, like, pyramid style authorization structure is a huge issue, because hackers will generally target high-ranking people in an organization with social engineering, like you alluded to, and they know that if I got a C-suite's login,
I got everything.
I'm golden. Side story, I won't say who, but I know somebody that got hacked, an organization that got hacked, and what was funny is it was a financial database system, and the hacker thought, I have access to payroll. I have, like, they were like, yes, this is awesome. Turns out it was a test box. So they had access to a bunch of data, millions of dollars, but it was a test system. It was isolated in a non-production server, which is another best practice, is have your production stuff completely siloed from your non-production.
Yeah.
So
physically siloed, because then that at least you've got that delineate. Like, yeah.
But I thought that was funny that this hacker probably, like, got an erection when he got in, and then he realized pretty quickly,
yeah,
this isn't real
worthless.
data. Yeah.
Well, and also with that too, like, it's also important to scramble your data if you're going to be doing any person identifiable stuff too.
Yeah.